Hi, my name is Rick Farmer. The project I have is MongoDB, another popular NoSQL database. We'd like to discuss what is MongoDB, how does it fit into the big data picture, installation configuration, Mongo basics, MapReduce with MongoDB, and the benefits and issues that I found with it. MongoDB is a NoSQL data store. MongoDB is a document-oriented database, has no predefined schema, therefore it does not maintain relationships between documents or collections. They're very independent items. Mongo uses Java syntax, which is very popular, although it does have drivers for most other popular languages. It uses a binary version of JSON data, but from this aspect of the viewer, it's generally very similar to JSON, and you won't notice a difference. Mongo can be scaled out to many clusters. The clusters can be configured with a number of replica sets, providing different redundancy. And they can also shard them. Sharding is the process of storing data across multiple machines. Basically, to scale Mongo, you just add more machines. Very simple. It's great for complex aggregations. It provides an aggregation framework that allows heavy transformation aggregation of data and a MapReduce mechanism. This is actually really interesting and what we'll look at today. We use scripted functions to aggregate the aspects of the underlying document and output that in an ad hoc basis or persist it back to Mongo. And it can handle very, very large collections, as you'll see. And it works against sharded collections, so you can distribute that automatically. For this project, I created a data science VM, which is a simplified way of configuring the data science environment using only code. It includes all of the projects that we've built for this class, everything from Cloudera, Hadoop, Yarn, Mahout, Spark, Java, Maven, and especially Mongo. The Mongo tooling has three main components: the MongoD, which is the database process, you need to have that running; the Mongo S, the sharding controller when you have multiple machines; and then Mongo, which is just the database shell, allows you to use interactive JavaScript back and forth. Mongo dump lets you take a snapshot, but the thing we're most interested here is Mongo import, which allows us to import our CSV file. The basics of Mongo is you want to make sure that the MongoD process is serving and running. That's very simple. Just follow what I have on the screen here. You type Mongo from the command line to start the Mongo shell. From the shell, you can write JavaScript and code it directly, or execute or build a JavaScript JS file and just use the load command and point to that script name from the Mongo shell. Once you've got your data created, the easiest way to look at it is to use a particular DB and then use DB stock histogram find. In our case, we're using stock data, and that'll show you everything that's in there. Really simple. MapReduce, basically given a collection of documents, allows us to extract the similarities. It's a built-in function for Mongo. An example would be db ibm MapReduce. It takes a map function that allows you to map your key value pairs and examine the Mongo database collection, and a reduce function that allows you to then specify your aggregation for the output stage of that. This basically, and then it also has an output for the results that you'd like to have, where you'd like to put those. For instance, here we're putting in we reduce output to stock histogram, which is the equivalent of a table inside Mongo. There's an additional finalizer process to let you do some more stuff before writing the output. So to simplify, basically we could do a vagrant up on our data science VM directory. Once that box is up and running, we just SSH into it, Cloudera at e63. We'll make sure that the services is started, copy all of our files over, and then run any shell scripts that we need to clean the data. In my case, I had remove comments.sh. From there, we just do the import. It's the Mongo import. The D flag at the bottom stands for the database. We call it stocks. We're taking in type file CSV. And the way I did it was I imported 300 or so separate pieces of ticker data for all time from 1970 to 2006 from the NYSE data source. So my table basically broke out to be date, price, volume, open, low, and high. And of course, I drop any table that I'm going to import into to make sure I'm not overloading the data. The MapReduce job that we made in this case, it basically runs a series of MapReduce jobs on the NYSE intraday trading data. It builds a histogram with $10 intervals of all prices for every ticker on every trading day between 1970 and 2006 for everything that was listed on NYSE. The intraday pricing data for each ticker becomes its own collection, which is equivalent to a table. So for instance, I've got an IBM and an EMC collection. The map function then sorts the prices into the histogram bucket ranges. The reduce function aggregates those counts for each histogram bucket. And then I also created a start map reduce function that allows us to iterate through each of the ticker collections one by one, calling the map reduce job for each of those. So IBM will get a map reduce job, EMC will get a map reduce job, etc. All output from the ticker map reduce jobs are aggregated in total to a collection called stock histogram, which contains all of the output data. And the full NYSE data set is very large. It's about 1 gigabyte for 2,833 symbols, representing every day of trade for each of those symbols from 1970 to 2006. That it was so large I had to reduce it to a randomly selected set of about 300 symbols. Running the map reduce job, basically you log into the Mongo shell, type Mongo at the CLI, you run the script that's supplied, load stock MapReduce.js, you wait for the data to finish processing, and then you view the results in the stock histogram collection using db stock histogram find. Just to give you a quick demonstration of that, in my VM, I'm logging into Mongo. You can see that it starts out at test. I actually want to use stocks, which is my database. From there, I want to load the stock MapReduce data, which actually shows that it's loaded. And then from there, I want to actually run my start MapReduce job. Start MapReduce function. And you see that it actually starts ticking through each of these one after another, taking each of the days of ticker data that are available for each of these tickers, collecting them, running a MapReduce job for each one of them, and aggregating all that data out. So we've got 327 ticker symbols that are in our collection. At that point, we have our output. We just do a db stock histogram find. So db stock and we see that we have all of our values bucketized. The way we set these up are intervals of prices. You can say it's ordered naturally. We have, for instance, in the top bucket, the range of $10 to $20, that of all those stocks that traded every single day between 1970 and 2006, we see that 172,971 times that the price was trading in the range of $10 to $20, and so forth all the way out to greater than $300. And in order to see more of the data, we have to type the it command, which is the iterator, and we can see that, for instance, greater than 300, we came out with a net of 888 tickers or prices that ran in that range for that day. So the problem solved here was that we automated the installation and configuration of MongoDB and the other tools used in big data analytics, the class, Hadoop, Spark, Mahout, etc. We used the MongoDB for big data analytics. We took a reasonably large data set and we were able to run MapReduce jobs against that and understand the MongoDB technology and how it relates to big data. Further, we're trying to demonstrate the MapReduce in MongoDB using that data. The MongoDB jobs itself looks, if you look at the stock reduce, we can actually step through this very quickly. You can see that the stock reduce basically has that function start MapReduce. It loops through and gets all the collections. We call them symbol. We go through each of those elements, and each time we'll actually call the MapReduce function. And we ask it to use the mapper and the reducer and then output that to the stock histogram. The mapper function is defined here and essentially takes the price data that's inbound from the that we've already loaded from the CSV file, and it determines based on an if-else condition where that fits in the range. So you'll see everything from less than 10 all the way out to greater than 300. Um, from there, we emit that. The emit is the key thing. You don't want to ever return in your map function. Instead, you emit. And essentially, the key for us is going to be this range title that we've given it. And then we want to send a count of 1 for each of those. The reducer is actually very simple. We basically take the key for each key, which is the bucket. We sum the values of those. And from there, we um, basically place that back in there for every key. So at the end of the day, we see that our reduce operation spits something back into our stock histogram table, which gives us our total histogram covering all of the data from NYSE crunched into a nice, neat histogram. So there were some issues that I came across. BSOM document size, the maximum size of a BSOM document is 16 megabytes. So the maximum document size helps ensure that you can't use an excessive amount of RAM. There is a way to work around that using the GridFS API. One of the other things was nested depth of documents. Because it's schemaless, you can go very, very deep, very, very quickly. But MongoDB supports no more than 100 levels of nesting of documents. MongoDB installation and configuration can be tricky. That was part of the driver behind creating the data science VM. If you happen to run into an issue where the MongoD database service does not start, just make sure that you've created the /data/db directory in the root. So in summary, we wrote infrastructure as code to create an automated build of the data science VM that includes all the software used for our big data analytics class, including our target tool, MongoDB. Then we loaded the set of NYSE historic intraday data from 1970 to 2006, and we ran a MapReduce job within MongoDB for each one of the tickers and all the intraday trading data for each of those tickers. From there, we extracted the histogram data of all the cumulative daily ticker prices within the entirety of the data set to understand the distribution of prices within the range. So for instance, as you saw, our low range was less than $10. That was the price it was trading. We did that in intervals of $10 up through a final bucket of greater than $300, which covers the daily trading data from the 1970 to 2006 period for all tickers that were represented during that time period on the New York Stock Exchange. We found that the pricing for most tickers on any given day fell into the range of less than $10. We saw that there was 226,536 times that a ticker had closed in that exact range. And we noticed also that as the price interval increased, that we see a general downward sloping effect as the values increase to the 220 to 230 range. That roughly hits about 105 times. And then when you get to the greater than $300 range, we often see that that's a catch-all bucket, which includes a lot of things. And for that, we saw 888 times the data. Here's a list of some of the references that I used. I found that the MongoDB manual was very, very useful for helping to get a good grasp of the commands. Mongo also is an open source product. One of the really nice benefits of Mongo being an open source product is that you can actually look at the source code. So when you have a question or want to know exactly how something works, for instance, a find or a for each, you could actually dig into the source code yourself and take a look at it. As I mentioned previously, Mongo supports many languages. There is a list of languages available that you can look at and see what it supports from a connection standpoint. And some other details around Mongo at scale, what it is, what the document databases are, something around the BSON spec, and then there's also some information around MapReduce and some other interesting things. Perhaps the most of it is that at the bottom is the CS Brown edu Pavlos stocks. That's where the data from NYSE was collected and used. Thank you very much for your time. appreciate your time and taking a look at this presentation. It's been a wonderful class.